All right, well, thank you all for coming. I know there's a lot of competition among the presenters to get people in the room, so I appreciate you all picking this talk on data breach resistant systems. My name's Martin Snyder. On Twitter, I'm at Martin Snyder. I'm the CTO of Wingspan Technology. I'm also an organizer of some of the local Philadelphia meetups and events, including this one, although I'm a small cog in the wheel that is Philly, ETE. And what we'll be talking about is one of the many things that we do at Wingspan. And because it's a security talk, we need to start with just a little background information to talk about, all the things that precede today's topic, just to make sure that we have a complete picture. So we're going to cover some background, and then we're going to get to the nightmare threats, which is what this talk is really about, which are the things that no matter what you do, there's not much you can do to defend against them. And this, then we're going to explore what our solution was to some of those concerns. So jumping right into it, there's two categories when you're talking about application security. You look at your development practice and you look at your operational practice. Your development practice, you're doing things, how do you write your code, how do you make sure it's secure, you can send it out for code audits, you can have penetration testing, you can review the library usage and check for things like that. Operationally, you're looking at the whole software stack, like all the things that compose your operational stack. And then in both cases, you're always looking at a monetary cost versus a labor cost. And you're trying to balance those two things. And you can never get it perfect. Like, for instance, you might invest heavily in an intrusion detection system. But you have to actually look at it for it to work properly, because these things, they generate noise. There's all kinds of elements. You can't be completely automated, just as you can't be completely manual. So you're always doing that. You have issues like key management software when you start to get into non-trivial numbers of cryptographic keys. Your monitoring is a big element, and all these things are dependent on exactly what you've done. And then there's all these categories of things that you're worried about. Like, for instance, you could imagine putting together a package for a running application where you list, because you've learned, you get a security notice on a mailing list, this library has a 0-day exploit, so you patch it. You could probably measure how many days in production that exploit was available. And you probably shouldn't, because the results will not please everyone. But you can determine like how many exploits have been live in your system, and then you can come on the other side and well, if somebody did use one of those exploits, would you have known? Like, how closely are you monitoring for signs of intrusion? And you put this together, and you can put like percentages on it, and the percentages are heavily influenced by how much you're spending. Again, both dollars and labors. And you can say, for instance, like, oh, well, we're 99% sure that nobody intruded, and we're 99.5% sure that if we're wrong about that, we would have detected some evidence. And then if you're unlucky, your evidence will be something like a news article about all of your data on the other side of the fence. And then you have to think about what you have and who's after it. Right? So there's this great example where how many people have a garden of any sort, right? How many people have ever had a deer problem in their lives? Okay, so deer problems are interesting. They come, they eat your hydrangea, they eat your hibiscus, they eat anything that starts with an H, and then they start, going for other letters of the alphabet. And you can stop them, right? You can buy bear urine and throw it on your plants. There's sonic devices. You can fence your yard and put a cattle guard in your driveway. You can do all these things to stop the deer. But it turns out that there's only one thing that determines the cost of solving your deer problem. And it's how much your neighbors are spending on solving their deer problem. Okay, this is important. This is really important when it comes to data security, because what you have, if you have something that other people have, okay, you just have to defend it better than the other people, right? So you have a lot of credit cards, and it's 5 years ago. If you have better defense than Target, not to single anyone out, because almost everyone's been breached at this point, then that was good enough. But you might have something that only you have, like political dissident communications or something of that nature. That's a whole different class of problem. Somebody wants that. You're the only one that has it. And now you have to be concerned about whole different types of attack vectors. And then who you're facing. And that's basically determined by the value of what you have. So we can look at some examples of a couple of things. This is more about the who than the what. It's an interesting game, right? I mean, there's a lot of game theory stuff of, the cost of defense versus the cost of attack, and it's an unfair game. It's unfair because the cost of defense is much, much higher than the cost of attack. The attackers can spend their money, and then they can attack multiple targets with it, but each target has to defend themselves individually, right? It's not fair. And the attackers only have to win once. They can lose 800 times in a row and then win once, and they just won the whole game. It's like Quidditch, which has the dumbest rules, right? That's a whole nother talk. So there's a lot of things that are tough here. So the first example, and there's links, and the slides are, I already tweeted the slides before I started, so if you can grab them off Twitter right now. The first one, so these guys, what they did was they built a entire network infrastructure, network and computing infrastructure to, it was creating fake sites that were not really playing videos with fake users that looked like they were watching the videos, and they siphoned $5 million a day out of video ad networks. And their infrastructure was costing them, tens of millions of dollars a month. I mean, how many people work for organizations that have less revenue than that, right? So you're talking, in this case, about very well-financed opponents. And in this case, they discovered it, they broke up the network, but they didn't catch anyone. So these guys are still out there and probably working their way back up to that number. And it's not exactly a penetration, but you don't know how they built that network infrastructure, or you don't know how they got started. They didn't start stealing $5 million a day, right? They started doing other things. And for instance, stealing credit cards and selling them on the black market to then finance other parts of the operation. You don't know all the steps that they took to get to that point. So they had a lot of stops along the way. The next one's interesting. So they know for sure that this guy and his team, they basically stole $100 million in a series of fraudulent bank transactions. They started with things where they would create accounts and transfer money illegally to them, and then have mules go and withdraw the cash and then bundle it up and FedEx it to Eastern Europe. And then they got much more sophisticated. And they took a break. They took a break, and then they, for 3 or 4 years, they came back, and they were more powerful than ever, much more sophisticated tools. And it was all electronic, and that was when they really ramped up the numbers. And I think we can all assume that if they have $100 million in confirmed illegal bank transfers, that they were well over $1 billion in real. I mean, there's no way that these, for that level of sophistication, that they figured out everything that was taken. So these guys were taking some serious money from in a lot of different approaches. The weird thing was the security researchers, and this is a long article, but it's really interesting about both sides, the attack and the defense. The security researchers saw some different behaviors when they came back the second time. And their network, which was basically facilitating all these activities, was also doing some things that are more consistent with intelligence activities, in this case, Russian intelligence activities. And it's an Eastern European Russian group in the first case. And what they think was when they took the break, they think they were actually caught by the Russian intelligence group. And instead of convicting and penalizing them and stuff, they basically cut a deal to let them keep running if they were also acting. So here, first case, we have basically well-financed criminals. Now we have well-financed criminals which have been turned and are also operating for a foreign intelligence service. So that's, you better hope that they're not your bad guy. And then the other kind of fun one was the Juniper issue, where they were shipping hardware that had some backdoor which had been basically committed to their repository. And I think people think the NSA did it, but it doesn't really matter. I mean, any number of US agencies could have done it, and the ones that didn't probably wish they had. And so it's, that's the who. So that's the traditional stuff. And so, the picture we're painting is that at some point you have to face the fact that there's a good likelihood someone's going to get in. You don't know when, you don't know how much they're going to get, you don't know all the circumstances, but you can't be 100%. No matter how much you spend, you can get close, but you can't be. But we're not even talking about that. So that's kind of where we are, and people have that mindset. There's a whole other category, and it's the privileged operators are a major attack vector. So you can have the what of what you have. Someone determines that what you have is illegal, unethical, a violation of something, and they want to make good by releasing that. They're not hacking your system, they already have access, right? That's a tricky thing. You can compensate people to mitigate that, but sometimes it doesn't really matter what the compensation is. You can coerce these people, right? You can bribe them, you can threaten them, you can do, there's a It's not a great movie. There's a movie Firewall with Harrison Ford, if anyone saw that. That's basically exactly what they did. It's the security expert, and they kidnapped his family and compelled him to act against the system that he created. You can have, and I know this is hard to imagine, you could have a judge who lacks full technical awareness might grant a subpoena for an overly eager prosecutor, right? And now you're served with this subpoena, and what are you going to do? As a way to compel a privileged operator to act against the interests of the system. And then you get another category of stuff, hardware theft is sometimes you would know and sometimes you wouldn't, right? I mean, like you might have, production and DR, most of your monitoring is on production. Like you may not even have intrusion detection in DR. Or you might not have as stringent monitoring. The fun scenario I thought is, so you have some really expensive enterprise NAS, with all these drives in some big array, and someone in the DR data center is basically taking the expensive drives out and replacing them with consumer level drives and selling your expensive ones on eBay, right? So that's a data breach. Your data is out there, right? You don't really know even what, where. I mean, that's a real, painful problem to deal with. If that information were brought to you and this was an area of responsibility for you, you can imagine just kind of, you put your head on your desk and you're like, I can't believe that I have to even think about this. So there's a lot of things going there. And then, when it comes to bribery, let's just imagine that you're in the middle of a presidential campaign and someone wants your emails, and you've actually run your email server in a secure fashion, and your users are aware of phishing attacks. So you can't just trivially steal all the emails, right? So that's the scenario here. But what if, the person that wants your emails, it just takes a briefcase with $10 million in cash and offers it to someone until there's a taker? Right? I mean, how sure are you that people are going to refuse that? Right? There's a lot of attack vectors, and none of the tools matter. Your percentages all drop to single digits. When you think of the number of people that have access to even a portion of the data and how much damage they can do. So we have a nightmare example. You guys might be familiar with it. Sometime in May of 2013, Edward Snowden left his workplace for the last time, and he took a trip to Hong Kong and a trip to Russia, and they report this data breach, and Obama has this famous statement about, well, what are we going to do? We can't send fighter jets after a hacker. And I've bold and underlined hacker, and I don't know if people are familiar with the circumstances, but regardless of his technical abilities and whether he might or might not be a hacker, Edward Snowden did not hack anything in this circumstance. Right? He was a system administrator of a SharePoint infrastructure, and he simply downloaded all the content he legitimately had access to. This is that whistleblower example. There's no hacking here, and hacking, of course, is a pejorative term, and they're trying to paint a certain picture, like, oh, well, this guy's some criminal mastermind, and he might be a criminal mastermind, but he wasn't in this case. He just took what he had access to, and then we get bonus content in this example, because Edward Snowden was using an email service called LavaBit to communicate with some journalists and stuff to share some of the information, and they got like a federal order matched with a national security letter gag order that basically said, you have to let the federal government act as a man in the middle for all of your users so they can steal their encryption keys, so they can decrypt the encrypted content, and they can see who he's communicating with, and they can start building a list of more people to go after. So now you have a privileged operator, in this case the owner of LavaBit, being compelled by court order. Now he basically defied the court order. He was found in contempt of court. He shut down the entire service for a number of years and reconstituted it with different technology and stuff. But these things are real. Like everything that we're talking about is real. We have examples of both the regular scenarios and the nightmare scenarios. So that's where we're starting. And so you think, look, we're encrypting everything, right? Encryption at rest is a best practice. We're doing this. We're doing all the right things. We have encrypted hardware. We have all software encryption. We have distinct keys for different categories of stuff. And this is an issue. It's an issue. There's a division, right? There's the people that work with security a lot, and so they understand the importance of key security. They put that like on a 10-point scale of importance with encryption. They'll put that at about a 15. And then you have the people that don't work with security a lot, and they put key security to 0. But it turns out, key security is not a trivial problem. You can encrypt all the stuff you want, but if your privileged operator has access to the keys, then it doesn't really matter. So there's there's hard challenges there. The other thing is, like, again, especially people that don't work with security as a primary responsibility, they think that like encryption's an absolute, like, oh, it's encrypted, therefore it's safe. And it turns out the safety associated with encryption is a function of time, right? So your encrypted data is, you know, potentially at risk to an algorithm where step one in the algorithm is wait 25 years. Right? That can be a real problem. And just, again, by way of example of this is everyone, I think people interested in security are familiar with Enigma and the World War II era cryptology and the counter cryptology. Oh, there's really fascinating stuff. So we're in 1942, and you know that's when they started breaking the stuff, and it turned out that only about 10% of the Enigma messages were broken in time to be actionable. By that I mean, like, they would rotate the wheels every 24 hours. And so basically, if you didn't crack everything in the first like 16 hours or 18 hours, you would have to start resetting for the next day anyway, and you would lose that window. So they only had that time period to break things. And so it turned out, like, if you're a fan of the Axis powers, that wasn't the worst possible outcome for having like a horribly broken cryptographic technology mixed with, you know, the enemy knowing things that you didn't know about it. But so fine, so even ignoring that, imagine that, you know, the message I'm sending is, you know, we're going to send, you know, here's the troop movements for the next week, right? So, all right, so that 10% chance that that's going to get, you know, be a problem or not. Okay, you can probably live with that. But what if the message you're sending, so you're a Nazi and you send an Enigma encrypted message, which is, hey, you know, this is the new name we're gonna put together when we move to South America. And here's the bank accounts and all the art assets that we're stealing and stuff like that. Well, now, you know, when you get to 1980 and computer science students are breaking these things for fun, and that message gets broken, then you're gonna have a bad day, right? And I know that, you know, no one's a fan of Nazis, or they won't admit it in public. You know, so it's like, oh, well, they get what they deserve. But again, now you start thinking about what is the content of your encrypted message, and what is the goal of the attackers against you. So encryption is very important, and all the other stuff we talked about is very important too. I'm not saying don't do any of this stuff. Do all this stuff. Do a lot of it. Do it well. But unfortunately, no matter how well you do it, you can still have a complete and total loss, unless you just don't store the data. Right? Find a way to limit what you store is the number one thing. But then we get to better ideas. We can distribute the data that we do store. And when you look at like the one part of security, especially in applications that people understand, is like authentication, passwords. Like people know the best practices for that. It's like you hash it, you salt it, you do this, and then you don't store the password hash in the same database that has the user information. Like that's one of the, that's like step 3 in the 10-point plan to protect user access. So we're doing it for password storage, but we're not doing it for other parts of our application. So you can spread it out, and that makes penetration harder. It makes reassembly harder. It makes it harder to, you know, grab, to put it all on a USB drive off of one machine and walk out the door with it. You can make this better by distributing things only via write-only connections. So think about messaging, like sending information in an SMS or an email, right? If your application can support something like that, then once it's sent, it's gone. Right? You can reconstitute it later, you can do things with the application, but that becomes very hard in a lot of scenarios for someone to reclaim the data. You can use database connections with write-only connections from the application server, and you can do things there. You can print or fax things, right? You're preserving the data, but you're preserving it in a way that can be written, but then not read back. And we'll get into some of these scenarios and where you would want to do them. When you store data, store it in non-reversible format. So again, with passwords, you can store it as a hash. But there's other scenarios too, where like a lot of the data that, you know, gets collected, you might only need it in aggregate form. You might only need it like in terms of populating a solar index. So in some cases, you can extract data back out of a solar index, especially through creative queries, but that can take a lot of time, or depending on the way you construct your indices, it may not even be possible. So you want to look for things like that. You want to do all these things in combination. And then always favor hashing data versus encrypting it, right? And there's a theme for all this stuff except for the first one, and the theme is these are all unidirectional, right? If you're really going to solve these problems, you're going to solve them long term. You're going to reduce that chance to 0, or you're going to take it from, something that can be done by someone in a tight window and you won't even know it's gone, to something that can only be done in concert by a great number of people working together over a period of time. That's the category that you want to be in. And we're going to need some tools to do this. We're going to get to an example application, and there's 2 tools I just want to cover. The first one that we're going to use are JSON web tokens. Like, how many people here are familiar with those? Yeah, so that's about half the room. And there's plenty of talks. I have one, but there's a lot of content out there on JWTs. A JWT is a set of independently verifiable claims. And what that means is that you can put this information out there. We're not encrypting the information. You can, but in our case, we don't really care. You're not encrypting the data. You're taking the data and you're putting it in a place where it could be exposed, but you can tell whether it's been tampered with. So the data itself, you can distribute it, you can put it somewhere, and you don't have to worry about the integrity of that data coming back. And then this is done by applying a cryptographic signature onto that payload. And there's a couple different ways you can do that. One is you can use a symmetric key algorithm where you have a private key and the person that signs the data and the person that verifies it both have the key. This is a good idea if that's the same person. It's a bad idea if they're 2 different systems or 2 different people. And so, of course, they have asymmetric key algorithms for that case, where you have a public-private key pair where one can sign it and the other one can verify it. But the key thing is that if you have the proper key, you can verify the claims without a database access. You're not reliant on any particular system or technology being available in a long-term fashion. Okay? And then there's other things that go into the configuration of the signature algorithm, the key length, the hash length, things like that determine the security. There's issues with JWTs. Like, JWTs are one of those things, it makes it very easy to do something which is fundamentally complicated, and that doesn't help a lot of people. Because it doesn't disappear the complexity of encryption. You can misuse these in a lot of ways and make your situation worse because you'll have this shroud of security that doesn't really exist. So one note is that you want to limit the claims. There's a lot of reasons for that, but the JWT, the size of the JWT will expand linearly with the linear size of the claims. So you don't want to put too much stuff in here. You can make them expire. It's optional. You should always make them expire. That should not have been optional. It was a huge mistake. And again, this is because of the temporal nature of encryption. This signature is potentially only valid for a certain time period. And it's going to be valid long enough. It's not going to inconvenience anyone. Years, many months, multiple years, whatever you want. But you should be rotating keys. You shouldn't just configure this application with one security key to sign this thing and leave it going for 10 years. Because if someone really wanted to figure out the key, that's a lot of time. And the format of the data is all very, very similar. You're exposing yourself to certain categories of attacks if you don't deal with that. The other thing is that because these are independently verifiable, you run into issues where they can't be easily revoked. So your system's going to trust this thing for as long as it's deemed to be valid. And the only real option you have, one is that you can add like a revocation mechanism to them, but that's going to take away the independence. Okay, so that kind of takes away one of the big benefits of JWTs. The second thing that you can do is you can just change the key on the fly, and that invalidates all JWTs that were signed, which is a very inconvenient thing to do. Again, more information available on that. We can also talk about it more in Q&A. Then we also want to use a cost-based cryptographic hash. These are used in passwords all the time. Most people are familiar with them. I put 3 on there, and they're in, they're listed in order of good, better, best. The notion of these is you want certain operations in your system to be computationally expensive, and you do that to mitigate against brute force attacks. Because if someone has a hashed value and they can do like 1 trillion tries a second in some big Amazon cluster, then they'll eventually get it. Especially if they know the length or approximate length of the data that's behind the thing. Bcrypt is the most popular one. Bcrypt actually has a flaw. Some people talk about it. It's not a mathematical flaw the way like SHA-1 was broken or something like that. Bcrypt's flaw is that the algorithm can be exceptionally optimized on graphics hardware. So you might tune the thing to take a half a second to compute on modern hardware, and you reasonably assure that 10 years from now it'll still take like maybe 1/10 of a second to compute. Meanwhile, like people today with some graphics card-based supercomputer are, again, doing this in milliseconds. And that's where scrypt comes in. Scrypt is specifically designed to not be optimizable on vector-based CPUs. And it does that by not just being CPU intensive, but also being memory intensive. And it's because like those cards, they have a lot of RAM, but they can't like communicate with RAM the same way that a modern CPU does. And so they kind of gums them up. And again, a solvable problem if you were motivated enough, but not that well solved today. And so you say, well, what are the odds that someone would fabricate custom hardware just to break scrypt? I mean, it'd be interesting to note just that Google's manufacturing chips to optimize machine learning stuff. They're pretty well funded. They're making custom hardware to optimize certain classes of stuff. And I went over some of the money that the bad guys are stealing. And then you have the intelligence agencies. So I don't think that you can really assume much, but you can just, everything falls into the category of always do better, pay attention, try to spike the costs, and when the next generation of cost-based hashes come out, migrate to them as quickly as possible. So the application that we use it as part of our recruiting process. We have a little workflow where we send people a written test and they complete it and they send it back. And we don't care when they take it. We're pretty liberal about that. We care how long they take because the time to take is sometimes an important measure, but it also mitigates cheating. Like if someone takes like 3 days on it, gives them too many opportunities to have other people take it for them and stuff like that. So we have this multi-stage workflow, and the application has to figure out, basically between 5 different circumstances of user. You have, someone that's just found the site and doesn't really know anything. You have administrators and the candidates. Either they're new to the system, they're in the middle of taking the test, or they're done. And so we have to figure this stuff out. And so what we're going to do is we're going to build this data footprint of the application. We're going to walk through this entire scenario, start to end, and we're going to see what data is stored by the system and where. Okay, so to start, the user, in this case, is the administrator. So the system's clean. We've just installed it for the first time. You have administrators. Administrators are defined in the configuration. We just have email addresses listed in there. These people can administer the system. So I go in as a regular person. I go to a link. I put my email address in. If I'm an administrator, it will email me a link. Okay, so it emails me a link that has a signed JWT in the link. Okay, so the only data that's stored is there in the administrator's email account, and the JWT, the claim, is just this person is Martin Snyder at wingspan.com. That's the claim, and because it's signed, when that JWT comes back to the system, it can trust, oh yeah, this person really is Martin Snyder. Okay? So now I want to invite someone to take the test. So I click that link and I come into the application, and the link includes the JWT, so now that's sent to the server. The server sees the JWT, it trusts it. It says, okay, this is Martin Snyder. He's on the admin list, so I recognize him. He gets the administration console. And now I go to invite someone, and I put their email address into that, and I click the invite button. And they get a JWT in their email. Okay, so I don't have any user accounts. There's no database records. If someone penetrates the system right now, they're going to be very disappointed. There's nothing on there that wasn't there when it started. And the links look identical. The system can distinguish who's an admin and who isn't an admin based on the configuration. It doesn't distinguish from them in the JWT. So there's nothing in there to spoof or do in the JWT. And if you were to somehow twist it and sneak a bad email in there, you still have to control the email. I mean, it still has to the message is going to come back to there. So that's a very challenging thing to get around. So now the end user clicks the link, and the site comes up and it says, hey, you're going to take this test, and here's the rules, and prepare yourself, and ask them a couple questions. Like, do you live anywhere near the office? Because if you don't, then then your choices in the available positions is limited, right? We don't relocate all the positions, and do you require sponsorship now or in the future? Because that's certain positions are more likely to have that, or you might be like at a really awkward time, like in July or August, where the annual allotment of visas have been totally exhausted, and so you have challenging questions of what do you do with someone that requires full sponsorship at that point. Should you even interview them in August, or should you wait until November or something? So you want to ask these questions, you want to explain what's going on, and so they answer the questions, they read the rules, and we want to store the answers to their questions. We have to do that every time, but we're just going to store it in browser local storage. Okay, we don't need to know that yet. Okay, so the administrator's logged into the system, the user's logged into the system, the user's primed and ready to take the test. We've still stored nothing on the server. So our exposure in a penetration, a data exposure is 0 at this point. So now the user starts the exercise. They click this big button. I'm ready to start the test, starts the timer. And we store a record in the database. And it's just these 3 things. I had to compress it for space. It's a cryptographic hash of their email address. It's an event, in this case, they're starting the test, and it's a timestamp, right? Because the system at some point needs to distinguish between the 3 kinds of candidate, right? It can distinguish between a regular user and a candidate based on the server configuration. It can figure out the unauthenticated people because they don't even have a JWT. But the 3 kinds of user, it needs to know what their state is. And you don't want to put that in the JWT because you can't rely on the original JWT coming back. If you sent them one that said, OK, they're started, and they might just use the JWT from before that said they hadn't started. So you have to store this on the server. It's required. And then they finish, they complete the exercise, they upload the files, they answer the questions, they do whatever. And it's going to make another event, and it's going to send an email to the administrator with the submission. The system itself doesn't need to know what they submitted. It just needs to know that they submitted, okay? Because this application serves to execute a workflow. We're not implementing a lot of historical data functions on it or something like that. We could erase these values from local storage when we send them. They get sent with the email, so the things that they're doing in this step are combined with what they did in the previous step and sent in that email. We're not going to store any of that, but I leave it on here just by way of example. It's still there. And then we review it, and we give them a reply. You're coming in for an interview, or you're not coming in for an interview. And so we have a event that they've gotten a reply, and we send the reply to them. So here's the final. That's it. That's the entire activity for a single user. Okay. So let's take a look at what our exposure is. We have 2 email accounts: our candidate email account and our administration email account. They both have JWT links, but they'll expire. So if you were to get access to those JWTs, you have to do it in a certain time frame, or they're useless. Okay? And the candidate one has already taken the test. So if you log in with that, there's nothing that candidate can do with it anyway. The administrator one is a different problem. How many people have ever played the game Half-Life 2? You ever heard the name Gabe Newell? Sound familiar? So he got his email hacked, and it ultimately resulted in the loss of the entire Half-Life 2 code base. This was before it was even released. A huge problem for them. Any organization you're in, if one of your, pretty much anyone, but especially a senior member of your organization gets their email hacked, you're done. I mean, that's pretty much the worst thing that can happen, because they will leverage that to get anything else that they want. They'll compel other people, to trick other people to do things. They'll have access. They'll reset your passwords. I mean, that's a clearinghouse. So you can never let that happen. So we're not even going to talk about potentially your email getting penetrated. But again, if it was, all they have is the test that the person submitted and the email address, which turns out to be valuable. The local storage is nothing, answers the questions no one cares about. Local storage is hard to get to. You'd have to get it to every single user in the whole system. You don't even know who they are, so we don't care about that. And then you get these database records, right? And so the database records turn out to only be valuable if you know the email address. When we go to that step where we give the person the reply, you log in as the administrator, you put the email address back in the system, and then it knows how to and make sure that they've taken the test and submitted it, and they're sending an email to the right person. The email address ends up being the key that unlocks the basic functionality of the system. So if you do steal the database, you have pretty much nothing. And it's nothing unless you also have the list of all the email addresses of the users. If you had that list of all the emails of the users, that ends up being more valuable by itself than what's in this database system. Consider the alternative here. Like, what if we had made people create user accounts, right? It's a system they're only going to use once. They're going to reuse passwords, right? You get a data breach then, and people come in. They know who your users are instantly from a penetration of your operational security or application security. They know who all your users are. They have their email addresses. They'll reverse the hashes for the passwords. They'll then get one of your users' Facebook accounts, right? And that's your fault. That's totally your fault, because you shouldn't have stored that stuff in the first place. You shouldn't have gotten the password from someone that's only going to use the system once. So you're basically begging them to create up the least valuable password they can think of that meets your minimum requirements or something. We don't have any user records. So that ends, the narrative. That situation is now completed for the one person. And there's a few things just to say about where this goes next. So the first thing is that we would not have deployed this system if we hadn't done it this way. The risks associated with a data breach on a system like this, the embarrassment and having to notify all these people that you've chosen not to interview. Now you got to, like 3 years later, tell them, oh, and by the way, we didn't interview you and we had a data breach now and we violated your privacy too. So you're welcome. It's just the worry associated with that, the ongoing operational and cognitive cost of having a system like that is too high to bother. Right? We just do it manually. Right? But with a system like this, it's well protected, right? And if someone gets in, there's really almost nothing there for them to take. But this doesn't mean, just because this one application is secured this way, that doesn't mean our whole process is secure, right? I mean, sure, you guys will all see there's some gaps here. There's an accumulation of data in email, and I kind of mitigated by that by saying, like, that's if your email gets taken over, this category of data loss is the least of your problems. But you can get accumulation in other parts of the system. You really need to be thinking about the security of the system versus the security of the assets, right? What are the assets? Where do they live, right? So in this case, like the real primary asset is that test submission that has the email address, it has the answers to the question, it has the submission for the interview process. That's the most valuable asset. So you want to make sure that where that ends up, it's safe. But the most important thing here is that you can move stuff like that away from the front lines. This application is an internet-facing application. You want it to be accessible to the users, right? But you can move it to a system that's much, much harder to get to. Now, can you air gap the assets? I mentioned before how one-way communication mechanism is to print things, right? You can imagine a system that instead of emailing that final bit, what if it spit it out on a printer? For these purposes, that might be good enough, right? You can still communicate with the person. You can evaluate the result, right? And then if you want, you could shred it when you're done. You can, all the gaps that you see as at the end of this exercise, they're closable if you continue the thought process. The value here is the thought process, the recognition that you have a responsibility to really limit what is being stored by the system, how long it's being stored, what can be done. You have to think in these terms. And then there's other things you can do as well. And a lot of it comes into, like, you think about how they protect nuclear weapons. But like, imagine, for instance, if I had like a system that was locked in a closet and the only thing connecting to it was like the slowest network interface card I could find, like a 10-base-T Ethernet card. And things are getting sent in some one-way fashion to that system, and I only view them on that system. And there's no USB ports. I've superglued them all, whatever's going on. You can imagine that even if the privileged operator got access to that system, you can make it take a long time to get the data, right? You don't want like a USB 3.0 high-speed device that can be connected to pull everything off. You can do things, you could put that behind a door with multiple locks where different people had the keys, where it required collaboration to get it. These are much easier to do when you have physical security, though, versus electronic security, because almost in every case, the electronic security can be defeated by someone that is a privileged insider. And then you can also do things like a klaxon-style notification. So one good example of that, when you look at the Amazon Echo, which is a fun privacy nightmare, one of the things that they say they did with it is they hardwired a light into the microphone. And so it's supposed to be impossible to turn the microphone on by any means through software without also turning on the light. That's an important feature if it works the way they say it does. And you can imagine something like this where if you did have it behind a locked door, if the locked door set off some alarm that sounded for a minute or something, or paged people or something, then you could you have a much better chance. You couple that with it takes 3 hours to copy everything off. There's things that you can do if you play this through to the end. I've listed some further reading. Bruce Snyder, if you're not familiar, he's a mathematician and cryptologist and a legitimate security expert. He wrote an article. I read this, I guess, a year and a half ago. Data is a toxic asset. It was one of the things that put me down this path. It's not long. It's a new way of thinking about things and people's responsibility towards the data that they store. Jared Overson, a completely different take. He has a video that I've listed here which talks a little bit about what bad guys do when they steal your data. And that's good to know. And one of the reasons that that's good to know is that one of my recommendations to everyone is that you should have some awareness at least of the street value of your assets. You know, it's like when you look at, you're trying to get investors for your company, you kind of know what the book value, the liquidation value is of some of these things. But people don't think of data in the same way. It's like, okay, well, you know, if some guy that didn't really care what I had stole everything, who would he sell it to and how? Because that's gonna give you a little bit of judgment of who might be after it. So the mindset is the most important thing, is just knowing that there are things that you can do that are better than what we're doing today. And you don't have to wait. It's hard to retrofit. But there's always opportunities to store less, I think, moving forward for all organizations. A term to think about, like people think about, use the least capable tool for the job. You hear that a lot for programming libraries and frameworks and stuff like that. It kind of leads to simplicity and easier to manage and maintain systems. Store data in the minimally useful representation. Think hard about what you need to do with this. It might be that your data only needs to live in an indexed format and not in a raw format. And you just need to back up the index the same way you would have backed up the primary data. And if you can build a system like that, you're going to be happier. Like all your costs go down when you do things this way. Your data size is smaller, your exposure is smaller, your operational footprint is smaller. If you're interested in seeing the application, you can shoot me an email at careers@wingspan.com and I can arrange that. And then finally, you should donate to the EFF. And that's important because no matter what people are doing from a technology perspective, there's other sides to this. There's educational elements, there's legal and political elements, and the kinds of people that would be in this audience and come to this conference are not well suited to tackle those problems. These guys are, so send them some money. And that's what I prepared, and I'm happy to answer any questions you might have. Hang on, we have a microphone.
So it seems the application is sending a lot of data to email, which seems suboptimal since email is already a bastion that's extremely valuable to breach. So putting more data in there just makes it even more valuable, makes it more likely that somebody will breach it because it's worth more effort to breach.
Sure. So that's a very good point. And there's a lot of other, and I hope people make them, there's a lot of other interesting points you can make about flaws of what we've done here. So one of the ways we mitigate that is we just delete the stuff when we're done with it. Like we don't really, there's no like long-term value in a lot of these materials for us. The other thought process is that in almost every case when we're dealing with this category of information, it's already all in the same people's emails. Like all the resumes and stuff are all coming into shared mailboxes and stuff like that. So in this particular case, we don't feel that it's increased exposure, but it is definitely a gap in the system. Another thing that we think about is, this is like a packaged discussion, right? It's packaged to fit in a certain space in our process, and it's packaged to fit in a certain time for this. I mentioned a few of the things we could have done, but if I was trying to do better, I would print rather than email. And that turns out to mitigate almost everything, because like deleting your emails, like you don't know how often that's happening or if it's being done properly, it might be recoverable. But if you're printing the stuff and that's satisfying your application requirements, then people get rid of paper more reliably, because there's more of a cost of leaving that on their desk. And if you have shred bins in your organization, which most places would have, it's perfectly convenient to destroy that in a very, very safe way. But to one of your other points is, if a privileged insider is working against this system long term, you're sunk, yes. Right? You're definitely sunk. And that's why, I mean, this talk is about building data breach resistant systems, which is a little different than building data breach resistant business processes. And it just depends. It depends. But this turns, I think it's a very nicely sized example of the technique. Hopefully it gives people ideas that they can apply. But I wouldn't be I wouldn't be running my political campaign through this system, for instance. There's a couple questions back there.
Let me ask you a question from a real-world scenario. Let's say we have two services, one behind a firewall that has no incoming rules and can only communicate outwards, and another one which is public-facing. Mm-hmm. The one with no incoming rules needs to be able to send one-way, potentially sensitive information to the public one. What would be some properties of that communication channel in order to keep that secure?
Well, yeah, so one of the things that is important is to determine like how important latency and the timeliness of the communication is. So you can imagine like certain queuing mechanisms might be more secure than things like just opening an SSL connection to it. But I don't really, I mean, I'm more on the application development side than the operational side. So if I did give you an answer, it would probably be immediately corrected by someone in the audience.
One more. You mentioned that bcrypt can be GPU optimized when they're trying to crack it. Can it also be GPU optimized when you're initially hashing the
Yeah.
Okay.
Yeah.
More of a comment more than anything, but thought it was very interesting at the end, part of your theme about a mindset of storing as little as possible. I find it interesting that, like, as an application developer, I find that the trend is to the opposite, which is to store absolutely everything, even if you don't know you're going to need it, because the data scientists might one day be able to find some very interesting monetizable bit of information in there. So whenever I ask my clients, hey, what should we store? The answer is always absolutely anything and everything you could possibly ever, who cares? We don't know if we're going to need it until we need it in a year.
Well, that's a great observation. That's why I think this talk is important, because there's a lot of businesses, especially the social media ones, they're in the business of data collection. They would not particularly be enthused by this message. And it's exactly the right, that's their attitude, is collect as much as you possibly can. And that's why, that message of know the street value of your data, I think that's important. Bruce Snyder's article, that's exactly what it's about, is that people are sitting on undisclosed liabilities, organizations like that. They're indiscriminately collecting as much as possible, not disclosing it even to their investors, right? They're not directly monetizing it, but they might have some extraordinarily valuable asset that, when breached, would completely obliterate the company. So there's reasons to not do it, even if you're in that business. I think that in Mayor's talk yesterday, he was talking about having limits on retention periods of things like observational data. So like someone gives you something, like they upload a picture, keep that forever, but you're recording their IP address they uploaded it from, their geolocation data, time of day. You don't really need that long term, and especially like that information becomes less valuable over time anyway. So it's a process to correlate these thoughts with that sort of organization. And there's other applications as well, where the entire purpose of the system is just to store a whole bunch of data, and query it in ad hoc ways where none of this guidance works. These things this is not broadly applicable. This isn't the kind of thing where everyone's doing it wrong and do it my way and you'll be happier. No, a very narrow area can be done this way. But the other thing to think about is the distance of the assets to the threats. That turns out to be an important thing. And you can imagine the mathematics around all this, where you're actually computing like risk factors for these things. So you put your accumulated data as far away from the front lines. And again, people are already doing this, but you can do more, and you can hide more behind one-way systems. So maybe your reporting engine is only accessible on a certain subnet, for instance, even though a lot of the data collection is happening at the web tier and has like a lot of VPN users or something like that. There's ways you can architect your system and architect your data layout to take advantage of this without changing what the application is doing. It gets back to, first fear the things that I was talking about, and then once you fear them, you decide how important it is to mitigate them. And I think this is a pretty powerful mitigation. All right, well, I'll be around for the rest of the conference if anyone has any private questions. So thank you very much for coming.